My handwriting is so bad, my phone camera doesn't even focus on this. Okay, so law of sines has to do with this like equation thing here. It's going to be like A, B, and C, three sides of the triangle, and then their corresponding angles, which would be like, if I draw this down here real quick, A, B, and C, the corresponding angles are the opposite vertices. We typically use the capital letters, A to A, that looks like a 9, B to B, and C to C. Just kind of thug it out and hope that you know which one's lowercase and capital if you're not typing it, I guess. Anyways, this means, like, it says it can be flipped here. This has to do with known sides or known angles. We use this one if we know angles. If we know two angles, then we can use that to find sides. And if we know two sides, then we use those to find the angles. So these guys, you would use them on AS or SSA triangles because you know two sides and an angle. And these guys you use two angles and a side, like down here. This one uses side-side angle or angle side-side. I love April. And we do this stuff. We don't know the sign of this. I believe right here we were looking for this number because this side corresponds to this corner. And we know these two. They have to like line up or else it'll be like, law of cosines. But this is about the law of sines. So we take the sides on the bottom because we're using this one, like from right here. The sides go on the bottom. This side is going to be angle that corresponds to the side that is known. So it's going to be 54, 101 degrees, sine of 101 over 54, times the known side with the unknown angle. And then over here it's going to be known degree, sine of the known degrees over their corresponding side. These guys right here, we didn't actually do anything with them, I don't think. Not even an ambiguous case. So I can actually whip something up for this really quick. Using this guy. Hopefully I actually make like a real triangle. Oh, that could be bad. We'll just go with like, 60 degrees. Make this nice and simple. So maybe 60 degrees. We'll say, man, I really hope this is actually a real triangle. Yeah, we'll go with those measurements. 4, and then we'll do the other angle be 60. We'll make this a nice equilateral. So that would mean all sides are just 4 because this is equilateral. Yeah, that's another thing. If you know the degrees to one side or the side to a degrees, and then you have another given degrees or side that's the same as either of these, then it's just going to be that corresponding number. I actually figured that out on one of his tests. So this one we have, we're going to be doing this stuff, which is the very first one that we didn't actually use at first, so go figure. Thanks, Mr. Reyes. And I have Desmos here for this, because I'm lazy. We would do this like, take this bad boy, we're gonna multiply by the sine of the fact that I need to put this in degrees mode. And then the stuff you're multiplying, like if you are finding a side, you need to be multiplying the degrees and having degrees on bottom. And if you're finding degrees, and you'd be having your sides on the bottom. Anyways, so we take 4 up here and do sine of 60, and that gives us 4. When you're looking for sides, remember that you do not have to do arc sine. However, if we do the inverse of this and we do 4 and 4 sine of 60, that gives us a number that we have to arc sine if you're trying to find degrees. If you want to find degrees, you have to arc sine. If you want to find a side, it should just give you your answer if you have a calculator. I really hope, yeah, we had a calculator for that test. Okay. Hopefully you still actually needed this video, or anyone who actually needs the video for future reference for my poor explanations. Okay.